Now this is a bead of mass m stays at a point P, A comma B, on a wire bent in the shape of a parabola. Y is equal to 4cx square and rotating with angular speed omega. The value of omega is without the friction. We are neglecting the friction. So this is the figure, and we can see that angular speed omega, this, and a parabola. Y is equal to 4cx square, and we have to choose the options. Now let's move to the solution. We have y is equal to 4cx square, so we differentiate it, that is dy by dx is equal to 8cx, and n cos theta is equal to mg, and n sin theta is equal to m omega square a. Tan of theta is equal to m omega square a upon mg, and tan of theta is equal to dy by dx is equal to 8cx. So we equate the both, as both are tan thetas. So 8cx is equal to omega square a upon g, and x is equal to a. We have 8ca is equal to omega square a upon g. So under root of 8cg is equal to omega. So therefore 2 root 2 of gc under 2 into under root of 2 gc, we have omega. So this will be our answer.